Hey, today we do a video about how to use the TF Grid version 2.3 and what we can do with that and how we can actually work it. And it all starts with actually getting yourself an online 3-bot administrator. And there's a very nice website to do that, and it's called the deploy.3bot grid. Again, I'll provide the links in the details. And if and when you go there, you need to have this 3-bot login application that is visible here, logged in and installed on your phone. This is the same one as you need in order to actually maintain your TFTs. So having said that, we'll use mine, and mine here will actually show that my account, as it is known by this 3-bot account, is Bernard Kuipers, that's my name. So let's say we're going to log in, and we'll use that same account to actually log in and be able to access and or launch a 3-bot online. As you can see, this is the same name. When I say sign in, I will get prompted on my phone to actually put in my PIN code, because this is a decentralized login which uses private and public keys to sign login requests posted somewhere central. My phone sees that central post needs signing. It asks me and it prompts me if I want to sign it. It challenges me in terms of, are you sure you want to sign into this one? I tell it yes, and then I just have to match the icon as a two-factor authentication, which I believe is this one. And by doing so, I am logged in, and that's all it takes. So now that we are logged in, you can see that there's a couple of the online 3-bot administrators already running. In order to get a new one, we just click new, and you can see me being logged in. I click new, and then I have to go through a number of simple questions. So first, what you want to do, I want to create one. I'll tell it next. We need to give it a real name, and as this is a test demo, let's call it a demo. And then we'll give it a little bit of information in terms of size. This is a paid for service, so the larger you choose, the more resources you choose, the more it's going to ask you for. And then in order to provide secure access, we don't work with username and passwords to get access to your 3-bot. Again, the login is already with the Threefold Connect app, as you saw. But then if you want to have access as a developer through SSH, that doesn't work with username and password. You have to share your public key and pre-load that into the 3-bot before it's being deployed. That I can actually, similar to the Threefold Connect app, with SSH as well, just identify myself with my private key. And then in order to actually be able to store and restore my 3-bot, I have to give it a password for the backup, which is again being securely stored. And now it asks me where I want to actually deploy this. So I've got a choice, either automatic, or I choose one of the farms that actually sits in the Explorer, on the grid. And all of these actually allow you to make a choice. So I choose the farm, here, then Explorer. Explorer, workloads.tf, there we go. And any of these farms that actually are available that have IPv4 and IPv6 are available here. So we can now choose one of the farms that actually has IPv4 and IPv6. Let's do Free Farm, which is ours in Belgium. And now it's being deployed, which will take a while. I can actually tell it to be able to send me emails if I have an email account with a email server that uses username and password and such, that I can be using that facility to send emails. Okay, so here we are, wanting to log in now to go and use some of the online 3bots. So let's do that again by typing in my name, as we've now seen before. Let's sign in, as we've seen that as well. So on my phone, I'll go to the 3bot app, and I will be prompted there to actually log in, which is done by the PIN code, as you can see. So I'll give my secret PIN code. It does check whether or not I am actually asking to log in, and then two-factor authentication. Choose the right icon, and I should be able to be forwarded to that particular site, which is happening now. All good. So this is the actual 3bot interface, the 3bot administrator interface, which on the left hand side you've got options in terms of actually doing and executing things. We will go through a number of those. I have to explain a little bit of the concept, and then I'll do a little demo with regards to actually showcasing what it can do and what it can do. There's a facility of a wallet in there, so this 3bot administrator is able to act on its own behalf in terms of stopping and starting things, and also refunding and updating things that need to be refunded. Right now there's nothing in there. This is, by the way, on mainnet, so these are actual TFTs. And then the first thing to explain is so-called capacity pools. A capacity pool is a pool of capacity, as the word says, that has been pre-funded. And as you can see, I've got a number of pre-funded capacity pools that actually are linked to farms. And farms, you can find those on the Explorer, are actually equipment owned by farmers that participate in building the threefold grid. So, for example, there's a big one in Austria that has a few sites, but if we go to Vienna, you'll see that there's a Vienna 1 and a Vienna 2, and if we make this Vienna 2, then you'll see that all of the servers, that are part of the Vienna 2 farm are 15 in total, and some of them are really not very busy and not doing much at this point in time. But that's how you can actually fund and say, I want to have future deployments in such a farm, and I want to pay for it. Again, the money is not being consumed, as you can see, because it says active and active storage unit, active compute units. None of these have active components in there, except this one, which is in Hong Kong, the Dragon Edge cloud farmer, in which I have my 3bot hosted. And as you can see, it consumes 0.25 compute units per second. I've got 1686 left, so I need to up that a little bit, which is what we'll do as a demo, and then I can also add and create extend pools. But let's update this one, otherwise I will lose access to my 3bot, maybe even during the demo. So, and there's already a lot of stuff in there that I do want to keep. So, create extend pool. We'll have a look at which pools are there, which we just saw, and then actually say that we want to extend. And again, this is taking the interface, which is a graphical interface, which talks me and walks me through in a question and answer type fashion to actually do what I need to do. So in this case, I want to extend. Which one? Because I've got a few, and I say that it is this one with 1653. I didn't give it a name, that's why it doesn't present a name. Now I want to give it one CU and one SU with a value of a day, and exactly 1 day, which means I'll add 86,400 CU seconds, and I'll add 86,400 SU seconds. Now we're being asked, how do you want to pay for this? Well, I've got an external wallet which exists on my phone, which we will go to. The wallet is here. In order to get into the wallet, it asks me my secret PIN again. Let's see if I still have enough funds to pay for these 11 tokens. So I should have, yeah, I've got 13, so that nicely fits. Let's go here, then say we want to do a transaction. I'll use the scan QR code, which is being nicely presented to me. I'll actually point it at it. It will then absorb all of the information, including the actual, let's say, memo, which you can see being highlighted and issued here as well. And then I'll just say send the tokens. Send the tokens. It will then ask me if I'm sure and confirm. Since I pushed twice, I might already have done that. And if so, there will be 11.99232 TFT sent to the actual farmer, which is again a farmer in, it's called Colin in Hong Kong, and he will have an additional 11 truthful tokens from me because I wanted to refund my capacity pool with him. So that being done, we have actually updated a capacity pool, and I should have enough life left for my 3-bot to continue this demo and to make that a worthwhile thing. So let's wait until it updates. And in the background there's a lot happening, right? There's tokens going from my account to his account. And then obviously it needs to be also accredited, and reservations need to be, or compute and storage unit seconds need to be put into my capacity pool, which will then actually be presented in the fashion that we were used to before. Let's do a quick pause. And here it is unpaused, just to make a little saving. It's done, it's finished, and we should be able to say finish. And then you can see in the new overview of the capacity pools that actually I have now another 86,400 compute units, and I shouldn't have done this. So I could have saved half the tokens in order to do so. So that is actually updating a capacity pool. So the next step is, with a refunded and fully operational capacity pool, to actually go and deploy some solutions. And within this 3-bot administrator, we've taken the liberty to make a few examples of actual things and how to deploy things. As you might know, there's many ways that you can actually deploy things on the grid. One of the interfaces is through this GUI-based question and answer. We call it the chat wizard, which will ask the relevant questions for specific deployments, and then it will actually execute the commands which underlying are still code base. We can see what that code base provisioning code would be. For example, if we want to deploy a network, well, all of the descriptions are here in the manual. The manual is publicly available to you, and you can see that in the end there is a very, very simple Python-based language and Python-based libraries that will allow you to do things in a very simple way. For the demo, I choose to basically use the GUI because that is still the most, well, let's say, interesting to see. I'm sure that some of you out there will actually want to go to code immediately. Let's do a deployment, and let's go through the steps that it requires in order for me to provide. Again, there's a few questions which need answering, and there's a few things in terms of information that you need to provide. As always, you need to provide a name, and in demos, things are always called demo. In this case, demo deploy. Since it is very specifically doing an Ubuntu deployment here, I actually have a choice of 1 or 2 versions of Ubuntu. I'll take the oldest long-term supported one. I can actually give information about how much capacity I want to give it, and in order to make this demo showcase, let's go back to this Vienna farm that we looked at earlier, and let's try to find a server that doesn't have any deployments right now. Let's say this one. It's called, as an identity, 9LMP. Let's remember that. It's got 0 cores that are being used. It's got 0 gigabytes of memory, and again, for the Ubuntu if you book and reserve cores and memory, you get free of charge 50 gigabytes, which is enough of actual, so storage will not be actually seen to go up. But let's go here. So we'll do, remember that, LMNP, and let's do a substantial size. Let's do 2 cores. Let's first see, there might be a better way of doing this. Let's go here to the other 3-bit deployer. Let's see what capacity pool we have available for Vienna 2. Because before spending it, you should see if and when I've got Vienna 2, Vienna 1, but it is Vienna 2. I've got almost a day worth of CPU seconds and almost a day worth of actual SU seconds, so that is very possible to do. So let's do that. So in order to make it visible, we'll organize 1/4, so a quarter of it, which is 16 cores. Let's do 16 cores. And let's do 65 gigs of memory, 65.6. I never remember how much that number is. We have a calculator. Let's do a calculator. 1, 2, 3 times 64 equals 65536. Should know that. 65536. And let's take 2048 2 gigs of actual disk space. Select the pool. Well, we said we would do Vienna. Let's do it here. We have, and I didn't go there and make a separate video for it, but you have to have a network which is being deployed for it. This is a network which is already existing, which I will use and reuse. I will just add the node on which we deploy to that network, which makes it accessible for me. And then in terms of accessing it, this is also really interesting. We don't use username passwords in those containers that are being deployed, because again, that is storing local state inside the container that presents a hackable service. So what we do is we preload it with my SSH public key, which means that I can log in with straightforward SSH access, and my SSH private key stored on my local device will actually enable me to log in, because the device has the public key and can check that I am actually representing the correct private key. I don't want to pick an automated node, because I said I would want to choose that particular empty one, and it was an identity that started with 9 LMP, so we'll take this one. And now I think we've answered all the questions that it needs answering. So it's about sizing, it's about do you want to have some external access and how, and do you want to have logs externally, and then you actually give it the specific node that you want it to start this container on. Now it's writing this smart contract for IT, which it will push into the blockchain database. That particular node, the 9 LMP, will discover that it needs to start this particular container with this particular, we call it an F list, this container file list, which it gets also, remember, over the network. There's no local image installed. And now it asks me to actually provide an IP address. So let's already start, in this case, to do the demo 193 dot. No, this is not what I want to do. Let's first see if I've got I've not got it up, so I need to go here, and then I need to do WG quick up plus slash WG epam. That, and now we can see that we do have, and this network is now in a tunnel from my laptop to this virtual network that exists on the grid. We can now do a network ping, because it will now be able to reach that node, and for argument's sake, let's choose the .6 one. So we'll start pinging the .6, which obviously at this point in time does not exist, but if and when I tell it that I want to have my container deployed with this particular IP, it will now write that into this blockchain database with this last bit of information. The node will discover it, and as you can see, the node has discovered it. It has downloaded the files that it needs to put to container. The container is now live on this server. Let's check that also from this angle, where we said we would actually take a look at this server 9L, no, wasn't that? So Vienna 2. We are now looking at 9LMP. We see that I took 16 cores. We see that I took 64 gigs of memory, and I think this small slice of memory was already there. It might have added 2 gigs, I don't remember, but you can rewind in the video and check that. But it discovered that it needed to do this, it did it, and therefore it has now deployed it. So super easy. If we then have a quick look about how that would work in terms of the actual code. So in the background, after answering all these questions, what code got deployed, and again, this is a description. This is in the end the actual command that will execute this. As you can see, I need to provide all the information that I got through the chat wizard and answered. So I need to have a network name. We gave it one of the 3 networks that I've got deployed. You need to give it an IP address, one of the addresses that was presented to me. I choose the flist string. Is the flist the image, the container image that is being loaded over the network, which was pointing to Ubuntu 18.04. We need to specify in which capacity pool it will exist. Well, we said Vienna 2. Is it interactive? No. This is a means of actually interacting with it during the boot process. If you wanted to, CPU and memory in terms of size, we did that. And then if and when there is a start command for the container, we give that as well. So easy to do through the chat wizard, but the chat wizard is just a more friendly interface that asks for all the right information and then executes the commands without making any typos. That's why I believe it's true. And then let's see if that private public key access also works. It is for always the root account, because you need access to start modifying and install applications and do whatever you want to be doing. So again, I now ask you to contact it. It will contact it. It's a new connection, so it will ask me if I really want to do this. And then with the private key signing the login request, with the public key being able to verify it, I am now logged in to my container in Vienna 2 on the server 9LMP something, which sits here, and that's it. So having done that, very simple single deployment of an Ubuntu container on a server in Vienna 2. Let's now go for a slightly more complicated setup and start doing storage. And in terms of architecture, let's talk through that first. We do storage in a very different way, where we have containers that operate a storage algorithm interface, S3 in this case. That's the first one we launched, and that's the one that's available today. And then it obviously runs on a node somewhere in this grid, but it can also have access to each and every individual disk in the whole grid, because the interface to all of that is exactly the same, whether it's in the same chassis, whether it's in the same data center, or whether it is 1,000 kilometers away. So that presents some very, very, very interesting capabilities, where you can, as an architect, as a developer, create your own storage solution. You can create your own storage solution by using disks that are local and very fast, and you can have a very performant storage solution. But then again, you compromise a little bit in terms of reliability, because if it's in a single server, in a single rack, in a single facility, obviously a facility outage will affect your solution then. So the other side of the spectrum almost is that you spread out your data by using disks in far and wide areas of the grid. Again, very reliable, but adding network latency doesn't make the performance go be better. So it's a design thing that you can do. In terms of the actual principle, what we speak about is that traditionally in IT, and there's many different ways that people approach this and have solutions for it, but it always comes down to creating multiple copies of the same data. And again, the old-fashioned rule, the rule that I've been brought up with, is that you have 1, 2, 3. That's a rule, 1, 2, 3. So 3 copies, one is live, one is being used, one is near live. If when the first one fails, you've got the second one to fail over immediately too. And then the third one is a backup sitting somewhere in a room with a lock or in a mountain remotely somewhere that you can actually rely on if and when the first 2 fail completely. Downside is, again, this is 4 copies. It says it's either the number of copies, or it's the number of copies times 100% is the overhead. So not very efficient. So by having done and innovated a lot in the storage space, Threefold has access to very, very novel and very innovative storage algorithms that work as follows. And again, that's why it's so important that on this grid you have access to many, many disks in many different locations. So the simple way to explain this is that any object or file goes into the storage algorithm, storage solution, and we refer to that as dispersed storage, where it's been taken apart, it's been cut up into data pieces, data blocks, data fragments. And those data fragments can be looked at, and that's a very fundamental thing, can be looked at as very large numbers. Again, a photo is a lot of zeros and ones. If you look at it in binary, it's in hexadecimal, a very large number in terms of hexadecimal. And again, as an example, a binary number. So if you take a file and you cut it into, let's say, argument's sake, 20 pieces, then you've got 20 fragments of data that represent very large numbers. And what we do in terms of storing that, we don't store those fragments. Many other storage solutions store those parts of data and data parts on different disks, and then they create additional data parts, which they call parity data parts, which allows them to, if and when one of those parts fail and are not retrievable, then with using this parity and the remaining original parts of the data, you can recreate the missing part. That's good and doable, and it works and it's out there. But we've decided a very different way of actually doing this, and bear with me for 1 minute to actually go through this, and then we'll do the demo. So as we make parts of digital objects and we create numbers, we took a mathematical approach to this. And the very simple example, or the very simple way to explain this, is to take 3 numbers, 1, 2, 3, and allow them to be represented by variables. So A equals 1, B equals 2, and C equals 3. What you can then do, you can then create 3 arbitrary equations. And those 3 arbitrary equations with the numbers filled in actually have a result. So A plus B plus C, arbitrary equation. If you fill in the numbers, it needs to equal to 6 because the number is 1, 2, 3. 1 plus 2 plus 3 is 6, right? C minus B minus A, 3 minus 2 minus 1 equals 0. So these 3 equations represent those numbers. And if you remember a little bit about what was taught back in secondary school, back in high school, about algebra, then if you have 3 variables, and if you don't know what the values of those variables are, you need 3 equations to actually be able to solve that system. And it's a matter of substituting that you can allow to find the values of those 3 variables. Now the magic starts here. Now you can imagine and you can create an infinite amount of these equations. You can just go on and on and on and on and on and create more. We don't do that. We create a number of equations that we need as a minimal, so in this case 3, and then on top of it we create, and that's called the storage policy, a number of additional equations that describe and that use the same variables and that are true, as also being able to be used in the solving of that algebraic system. Now we don't store the data parts. Again, the data parts are the numbers are the values of the variables in the equations. We store the equations, and we store the equations on many different disks. So lots of advantages. The disk with the stored equation on it doesn't have a meaning because you don't know what it is. It's an equation that describes something with 3 variables, and as you don't know the variables, you don't know, and you're not part of the original data object. You don't get that. But it allows for retrieval of the object if and when you want to go the other way, where the stored parts or descriptions of parts of data need to be reconstructed into the actual file. You can get any of these 5, if you stick to the example of you need 3, any of these 5 are good enough to solve the system. This is very different than what others are doing, where you need to retrieve the original parts of data. And when you have retrieved the original parts, all of them, then you can reconstruct the data object. With us, it doesn't matter. Any of the first 3 that come back, if and when that dispersed storage algorithm asks all of the disks to give back the equations, any first 3 is enough to start recreating the object. So very, very interesting, and can talk for that for hours, but let's not do that here because that's not really a demo, that's more of a workshop. And if we now go back and take a very simple approach to start, why can't I find the right window, of starting actually an S3 storage. In the S3 storage, we'll want to build over a number of different capacity pools. Remember, capacity pools is pre-purchased potential to launch workloads on different capacity pools, and let's look at where we can do it. So what do we do? Salzburg, Frankfurt, and Vienna. And then we'll create a number of disks in Salzburg, we'll create a number of disks in Frankfurt, and we'll create the S3 head in Vienna, which means that you will see, if we go back to the capacity pools later on, that all of these active storage unit numbers for both Salzburg and Frankfurt will represent a particular number. And in Vienna, you will see that the actual consumed compute units, because that's where the head is, the dispersed storage algorithm, will actually start consuming capacity seconds. So here we go. S3. And again, please fast forward if you want to skip that first piece, which I will state and restate in the beginning of this demo as well. So S3 storage, same principle, chat wizard, we go through it. Let's do a demo S3, as always the same boring name, but that's what it is. We can go either single or double, primary and secondary for redundancy reasons in terms of writing and reading. For argument's sake, right now in the demo, single is enough. We have a choice to actually do spinning disks or SSDs. I'll use SSDs because they provision faster. And then we can say per disk, and the actual name we use for it is ZDB. Per disk, how much data do you want to reserve? And in my case, I'll make it 100 gigs. How many resources you want to give to the actual head in Vienna to be taking retrieval and write commands. Then let's try to do 3 disks in Frankfurt and 3 disks in Salzburg, which are 6 in total. And let's then add, again, this is the storage policy, so we'll get each and every object to create 6 equations. Let's add, for redundancy purposes, 3 equations per. Well, let's make it 2. So 6 original pieces of data, descriptions of data, and 2 redundant ones. So in total, we'll use 8 ZDBs that are spread over a number of farms. We said we would do Frankfurt and Salzburg. We have sufficient funds in there to do so. Those are the 2 sites that we will be using. And we will push the actual dispersed storage plus S3 interface onto the location Vienna, again remote. It's not going to be the most performant solution, but it definitely spreads 3 main cities in Austria. And it will, so here we go, Vienna 1, or Vienna 2, it's called Vienna 1. Select automatically, yeah, I don't really want to prescribe. And now I think we've provided all the information that it needs. It will construct this smart contract for IoT after I have told it where to connect and what to build all of this. It will tell me that my access code is this particular one, and I don't need external logging. I might want to have access, as we did with the Ubuntu, through a secure SSH login. And now it's seeking if it can actually deploy, if it can actually find nodes to do these deployments on. And it's now writing into that blockchain database one by one specific descriptions in terms of what needs to be done by these specific nodes. So most of it is done. Now we can actually present information that will speak which network it is, and let's see if we are still connected. Yes, the VPN is still up and running. Let's do the same thing as we did with the other deployments. So with ping 10.193.5.6. Again, that thing is not up and running. Specified the IP. We'll write that piece of information into the blockchain database as well, where now the server in Vienna will find out that it needs to get the F list for this S3 plus dispersed storage container. It will actually write or get that container downloaded in terms of the applications. It will do the checks and verification to check that it's downloaded the right version and actually execute that. Give it a little bit of time, a few seconds. I shouldn't have pushed pause, but it's now deployed. As you can see, container is up and running. It returns to my ping, and I've got an address which I can now connect to actually get the Mindoreo S3 interface. We use the Mindoreo front-end gateway functionality. The back-end in terms of the actual storage is 100% ours. And that's not what I wanted to show. Paste. This is where I wanted to go. And the access key was my name, this one. And the secret key was secret 1, 2, 3, 4, 5. And there we go. That is a setup with regards to a demo bucket. Let's upload a quick file if I have anything that is of decent size to the visual code editor, 65 megs. Let's push that in. So again, send it to Vienna 2. Then Vienna 2 will send it actually to disks, slices that are actually being distributed between Frankfurt and Salzburg, which we can see. Let's successfully upload it. It's now here, and we have access to it. If we now go and reload this particular page, it will then say, as you can see, that it is consuming storage unit resources in Frankfurt and in Salzburg, and that it is using a lot less storage because, again, there is some caching, there is some log caching that happens within the dispersed storage, and we're using a quarter CU in the Vienna setup. So we're using 2 sites and this one, and it's all working nicely.